In this video, we're going to talk about using the acidic and basic properties of a molecule to aid in their separation. And in particular, we're going to talk about acid-base extractions. By extraction, we're talking about the separation of two solids based on their differential solubilities in two liquids. So one of these solids will be more soluble in one liquid than in the other liquid. Remember, our Bronsted-Lowry definition of an acid is a compound that's a proton donor, and our Bronsted-Lowry definition of a base is as a compound that's a proton acceptor. When we talk about separating molecules out of a mixture, we're going to think about categorizing those molecules as strong organic acids, weak organic acids, bases, or neutral organics. For our strong organic acids, what we're going to be talking about are carboxylic acids. Carboxylic acids have the structure that is shown here. They have an acidic proton right down here, which has a pKa of between 4 and 5. As a stronger organic acid, it can be extracted with a weaker base, and this is going to be important in our schemes. When we talk about weaker organic acids, we're talking about phenols. The structure of phenol is here. It has an acidic proton down here. As a weaker organic acid, it's going to be deprotonated with a stronger base. The pKa of this proton is about 10. And so the differences in these two pKa's between 4 and 5 and 10 dictates the strength of the base that we're going to use to pull them off and changes what our purification scheme looks like. For organic bases, we're primarily going to be talking about amines, nitrogen-containing compounds, and then anything that's not a strong organic acid, a weak organic acid, or a base, we're going to categorize as a neutral organic molecule. And I've shown the structure of benzene here just to show you what one looks like. Okay, so when we're doing an acid and base reaction, what happens? If we've got a stronger organic acid, like a carboxylic acid, it reacts with a weaker base, like sodium bicarbonate. The acid donates its proton to give us the deprotonated carboxylic acid. This is the conjugate base of that carboxylic acid. The base accepts that proton to give us, in this case, carbonic acid, which is the conjugate acid of sodium bicarbonate, and this dissociates into solution to carbon dioxide and water. The important part about this reaction is you started with a neutral carboxylic acid, and what you formed is an ionic deprotonated carboxylic acid. This ionic version is now soluble in water, and that's going to be important in the extraction process. If we have a weaker organic acid like phenol, it's going to be deprotonated with a stronger base like sodium hydroxide. As it gets deprotonated, we form the phenoxide ion. Again, this is an ionic solution. It's charged. It's going to be soluble in water, whereas the protonated phenol is not, and that's going to be important in our separation. If we talk about an amine, it's going to accept a proton from an acid like HCl to form the ammonium ion. Again, the ammonium ion is positively charged, which means it's going to be an ionic species. It's going to be soluble in water, whereas the amine that you started with isn't. And again, that's going to be important in the purification protocol. Okay, general concepts of extractions. This is what an extraction is generally done in. It's called a separatory funnel. It's got a stopcock here that's closed to keep the liquids in it. It's got two different liquids in it that are not miscible. You have to have two liquids that will not mix with each other to be able to do an extraction. So in this separatory funnel, there's an aqueous layer on the bottom, and it's got some compounds in it. And there's an organic layer, which in this case is less dense, something like ether on the top, and it's got some molecules in it. And what you can do is open the stopcock, let the aqueous layer come out of the separatory funnel, collect it in a flask, and then the compounds that were dissolved in that aqueous layer are now separated from the compounds that were dissolved in the organic phase. So general concepts, you need to have two insoluble liquids. You need to have two layers, for example, ether and water. The solids must dissolve in a solvent that is insoluble with the other extracting liquid. Again, this is saying you've got to have two different layers here. And if you've got organic liquids instead of solids that you're trying to extract, you've got to take those organic liquids and dissolve them into another liquid first before you do the extraction, so that again, you have two different layers. Okay, so let's look at an example of a mixture of compounds that you have that you could use an acid and base extraction for. So the first thing that you're going to have to do is find a solvent that this mixture of compounds that you want to separate will dissolve in. Once you've done that, then what you want to do is think about how your extraction could happen. So classify each of the compounds as either a stronger organic acid, a weaker organic acid, a base, or a neutral organic. Benzoic acid, this is a stronger organic acid. We'll say SA. Phenol, this is a weaker organic acid. So we'll call this WA. 4-methylaniline. If you look at this, this is an amine. This is a base. An anisole, it doesn't have a carboxylic acid, it doesn't have a phenol, it doesn't have an amine, it's going to be a neutral organic. Okay, so thinking about, once you've done that, you can start to think about what a purification scheme should look like. You've got two acids, you've got a base, you've got a neutral organic. There are more than one way that you could use, more than one order of separations that you could use for this purification protocol. I'm going to take you through one, and I'll let you work on another on your own. So let's start with the acids. If we first wanted to extract out phenol, phenol's a weak acid. To pull this proton off phenol, we're going to need a strong base to do that. But if we pull this proton off of phenol with a strong base, it's also going to pull this proton off benzoic acid, off the carboxylic acid. And so you're not going to be able to separate those out in that way. And so it's going to be better to start the other way around. Start with the strong acid, because you can pull this proton off with a weak base that's not going to pull this proton off. So if we take a look at what that could look like, we've got our 4 compounds here. Let's add a weak base, sodium bicarbonate. It's going to pull the most acidic proton off of the carboxylic acid to make it an ionic compound. This ionic compound is now soluble in the aqueous layer in our extraction, and so we can drain this out. So we'll separate this out in our aqueous layer, and in our organic layer, the other 3 compounds are left. Now, once you've got this aqueous layer separated from this organic layer, what you're actually going to do, you're going to add HCl and reprotonate that. So you regenerate your carboxylic acid, add ether, again, shake it up in your separatory funnel. This is going to now go into the organic layer. The reason you want to put this back in an organic layer is that ether is a lot more volatile and has a lot lower boiling point than water does. So it's going to be a lot easier to separate that out from benzoic acid. Okay, so in this way, you've separated benzoic acid out. All right, so now we can go to phenol, which is the weaker acid with strong base. We can deprotonate that to get the phenoxide ion here. Again, this is an ionic compound. It's soluble in water. This will be the bottom layer in our separatory funnel. We'll drain that off. We've separated now phenol out. Again, what you're going to do with that phenol is you're going to reprotonate it to get back your original compound. You'll add ether to it, pull that back into the ether layer. And again, the nice thing is ether is really volatile. You can pull it off on a rotovap quite easily and regenerate your phenol. So you now have your organic layer with 2 compounds in it. You've successfully pulled 2 compounds out of this mixture. What do you want to do next? Well, you have an amine and a neutral organic. Nice thing about an amine is if you add an acid, you're going to protonate it to form the ammonium ion. Again, this is an ionic compound. This will go into the aqueous layer in your separatory funnel. You can pull this off, and now you've separated your amine out from the organic layer. The organic layer here just has anisole in it, and so that's separated as well. So in this way, you've separated all 4 of your compounds out. Go ahead and think through other ways that you could do this separation purification, this separation protocol.